So why don't we work through example 6 together? And then, yeah, let's work through example 6 together. So example 6 says, use both the left endpoint approximation and the right endpoint approximation to approximate the area under the curve of f of x equal to x squared on this interval from 0 to 2. Okay. So my other class wanted to see a picture. Do you guys want to see a picture? I mean, I'm guessing you want to see a picture, right? Oh, I'm going to give you a picture anyways. So let me graph the situation here. So I'm going to go like this. I'm going to say, here's 1, and here's 2, and here's 1, 2, 3, 4, like that. And I can even subdivide this. This would be 1/2, and this would be 3/2. And I can graph my curve. My curve is f of x equal to x squared. So, I can create 3 points like this, and I can do my best to sketch this curve like this. So this is f of x equal to x squared. Looks a little cramped. Let me move it. Move it there. Okay. This is the x-axis. This is the y-axis. And I'm going to need 2 pictures because I'm doing 2 separate problems. So let me copy this. Let me paste it down here. That's for the second one. So let's do left endpoint first. So if we're doing left endpoint, the thing that we're trying to calculate is it's going to be L something. And then they tell me that N is equal to 4. So we're really going to calculate L4. Okay. So how do we do this? I'm worried you look at this, you're like, what does this mean? So I'm just trying to say, calculate L4. So the first thing that we need to do is we need to calculate what delta x is going to be, the width of each rectangle. So delta x is equal to b minus a over n, and that's going to be equal to I guess to make it clear, I should label a bunch of things like f of x is equal to x squared, my a is equal to 0, my b is equal to 2, and my n is equal to 4. So if you can establish all that ahead of time, then it becomes easy to calculate all the different pieces. So this will be 2 minus 0 over 4. This is equal to 1/2. Okay. So we definitely need that. Now, earlier I had said that the first step is you take your interval and you chop it up into n equal pieces. And then the second step is you find this delta x. So I hope you can see we have like 4 pieces, 1, 2, 3, 4, like this. And because this is our first example, I want to explain it in a little bit more detail than is necessary. So our goal is to approximate the area. And the area is approximately equal to the area of the first rectangle plus the area of the second rectangle plus the area of the third rectangle plus the area of the fourth rectangle. And we're going to calculate what each of those things are. So why don't we draw our rectangles on this picture here? My first rectangle, I'm using the left endpoint, so the y value is 0. So that first rectangle isn't even a rectangle. It's like a horizontal line. The second rectangle comes up here. That's our second rectangle. The third one comes up here like this. That's the third one. And then the last rectangle comes up like this. Is there any questions about my picture here? No questions. So we want to find the areas of each of those four. So I told you I'd write down a few extra steps that are necessary. I'm going to write out what the area of each rectangle is. So how do I find the area of the first rectangle? I'm going to take my function, I evaluate it at 0, that gives me the height, and then I multiply by delta x, which was 1/2. For the second rectangle, I'm going to evaluate my function at the x value of 1/2, and then I multiply by the width of the rectangle, which is 1/2. For the third one, I'm going to evaluate my function at 1, and then I'm going to multiply by 1/2 because that's the width of the rectangle. And for the last rectangle, I evaluate my function at 3/2, and I multiply by 1/2 because that's the width. So I'm going to add the results of all those together. Does that make sense for everybody so far? Is there any questions? All right, cool. So let's do this. So this is going to be 0 squared times 1/2 plus 1/2 squared times 1/2 plus 1 squared times 1/2 plus 3/2 squared times 1/2, because my function is squaring. So I have to square each of those values that I put in. Okay. When you do that, you're going to get 0 plus 1/8 plus 1/2 plus 9/8. And if you stuck all this into your calculator, you get 1.75. We don't have any units here, but we want, I'm just going to put units squared. So why is it units squared? If you think about it, we're dealing with area. So if you've ever rented an apartment or something like that, they always measure the floor space in square footage. If you think about it, square footage makes sense, right? Because you have 1 foot, then 1 foot, and then when you multiply the two edges together, that gives you the area. So a foot times a foot is a foot squared. So that's why it's feet squared. In our case, we're not specifying units, so it's going to be units squared. Does that make sense? Is there any questions? All right. I want you to I want you to calculate R4. Okay. Do that for me, please. So I apologize if you're still working. I'm going to start talking about it. You'll probably finish before I finish. Once again, just to reiterate the process, you start with your interval from 0 to 2. You chop it up into 4 equal pieces, for this problem at least. Then we're going to figure out what our delta x is going to be. So delta x, we already calculated up above, but it's b minus a divided by n. In this case, it's 2 minus 0 divided by 4, which is 1/2. And again, I know we did that already. In this case, we're going to use the right endpoint. So that's going to be R4. And to figure that out, we need to evaluate the height of our function, which is, for the first rectangle, is going to be 1/2, and then multiply by the width, which is 1/2. For the second one, the height is going to be f of 1, and then the width is just going to be 1/2 still. For the third one, the height is going to be 3/2, and the width is 1/2. For the fourth one, the height's going to be f of 2, sorry, and the width is 1/2. Is there any questions about this first step? Or first 3 steps, whatever you want to call it? No questions. Now in this case, my function is the squaring function. So I'm going to square each of those guys. So it's going to be 1/2 squared times 1/2 plus 1 squared times 1/2 plus 3/2 squared times 1/2 plus 2 squared times 1/2. And what do you notice? If you took a look at this guy, I don't know if you noticed, the first 3 terms here are really the same as these 3 terms right here. And this first term was 0 anyways. So actually, the sum of these first 3 are automatically going to be 1.75. And then you just got to add the 2 in, because 4 divided by 2 is 2. So in the end, you should have gotten 3.75 units squared.